Newton is considered by many to be history's most accomplished individual. Had young Isaac Newton not left London in 1665, he may have succumbed to the Black Plague, and the world might be a different place today. We have previously looked at problems involving bodies undergoing uniformly accelerated motion. In those problems, we did not consider the forces acting on the body. In this video, we will now use Newton's laws to acquire the necessary information to solve problems involving uniformly accelerated motion. Demonstration problem. The block shown below is sitting on a horizontal surface and has a mass of 2 kilograms. If the magnitude of the horizontal force F shown below is 18 newtons, how far will the block move in 5 seconds if it started at rest? The givens. The magnitude of force 1 is 10 newtons. The magnitude of force vector 2 is 8 newtons. The magnitude of force F is 18 newtons. The initial velocity is 0 since the block started at rest. The time is 5 seconds. The unknown. How far will the block move horizontally? That is, the displacement is what? As before, we go through the need 3, fourth is what, fifth not known process to find the correct uniformly accelerated motion equation for this problem. We know the time is 5 seconds. We know the initial velocity is 0. We're looking for the displacement, but we know that we only have 2 things, and to solve the problem, we need 3 things. We are given something about the forces. To solve the problem, we must apply Newton's laws. We can see that with a force of magnitude F 18 newtons to the right and F2 of 8 newtons to the right, while F1 is the only force to the left and it has a magnitude of 10 newtons, that the forces are not balanced, and therefore Newton's second law applies. That means F net of x is mass times acceleration along the x-axis. Substituting, we have for F net of x, F1 of x plus F2 of x plus F of x is mass times a sub x, where F1 of x is minus 10 newtons, F2 of x is plus 8 newtons, and F of x is plus 18 newtons is equal to the mass. We're given that the mass is 2 kilograms times a sub x. Evaluating, we get 16 newtons. Net force is 2 kilograms times a sub x, or a sub x, which we can simply write as a since we're only working with one axis, is 8 meters per second. Now, for the motion problem, we do have the 3 things that we need. The givens now are the initial velocity is 0, the time is 5 seconds, the acceleration is 2 meters per second. The problem we're faced with is how far will the block move in 5 seconds if it started at rest. This means we need to solve for the displacement s. In the 5 things that we have for uniformly accelerated motion, we have 3 things. We know the time, we know the initial velocity, we know the acceleration. We're looking for the displacement s. This means that the equation that will work is the final velocity not known equation, or s is v initial t plus 1/2 the acceleration times the time squared. Substituting in, we get that the displacement is 0 times 5 seconds, or 0, plus 1/2 times the acceleration, 2 meters per second, times the time, 5 seconds squared. And evaluating, we've answered the question. The block will travel 25 meters. Now it is time for you to work some problems.